Hello, welcome. In this lecture, let us discuss what is bottleneck. If you look at this picture, you can see here is the neck of the bottle where the throughput gets reduced. Suppose this bottle is filled with water and its capacity here gets reduced, and flow of water out of this bottle is limited to the capacity of this neck, right? Something similar happens in applications as well, that is called bottleneck. Here flow, in this picture you can see here flow of the water is constrained by the capacity of the bottleneck, right? Here neck is smaller compared to the body of this bottle, and the capacity or a throughput or a rate at which water can come out is dependent on this capacity of the neck. Here let us look at the real world example. Suppose you have a road here. Here there is a capacity of running a 4 vehicles parallelly, and here also there is a capacity of running the 4 vehicles parallelly, but here in between only 2 vehicles are able to pass through in this area, right? This is a bottleneck. Even though capacity on either side is 4, overall capacity will be only 2, because at this point only 2 vehicles can pass through at a time. Hence the throughput gets reduced to 2, even though capacity of the road is 4 on the either side, right? Because of this bottleneck, entire capacity gets reduced to 2 itself. So the definition of the bottleneck is a point in the system where performance get constrained, leading to reduced throughput or increased latency. A point where performance gets constrained, it is leading to the reduced throughput or increased latency. This is called bottleneck. Remember, performance gets constrained and it reduces the throughput and increases the latency, right? This is the bottleneck. Now let us understand the bottleneck in an application with this example. Here is the client, and users can send a request to the web server, and web server has a capacity to process 1000 requests per second, and web server in turn sends a request to the application server, which also has a capacity to process 1000 requests per second. Whereas when the application server sends a request to the database server can only process 100 requests per second, and hence even though web server and application server are able to process 1000 requests, and when they request the data from the database server, it is able to process only 100 requests per second. Hence this is a bottleneck, and overall capacity of the system gets reduced, and overall this application in overall able to process only 100 requests per second, because database server capacity is limited to 100 requests per second. And we need to eliminate this bottleneck, or we need to find a fix to this bottleneck. We can improve the capacity of the system to process 1000 requests per second, since web server and application server are already capable of handling 1000 requests per second. So to resolve this bottleneck, what we can do? Some of the possible solutions include optimize the database query, add caching to reduce the database load, scale the database server horizontally. It means you can add a more database servers, or vertical scaling, which means use the more powerful database server which can handle 1000 requests per second, or we can add 10 servers, or we can add 10 database servers. That is called horizontal scaling. We can add 10 database servers which can, each server will handle 100 requests per second. Overall it will be able to handle 1000 requests per second. And these are the possible solution. You can optimize the query and check. You can add the caching technique to reduce the database load time, right? And also you can apply horizontal as well as vertical scaling. By addressing this bottleneck, you can improve the overall performance of the system, right? This is about the bottleneck. Now we have understood what is bottleneck. Another video we will understand in detail what are the different possible types of bottlenecks and what is the solutions or what is the approach to resolve those bottlenecks. Thank you for watching.